everyone, I'm Xiansheng Math, and in this video, this is part 4 of how to convert a decimal, one that does not terminate but eventually repeats into a rational number in fraction form. You'll notice a similarity between this decimal, 0.713 with the 3 repeating, and 0.7 repeating, that there's just a single digit that repeats. The difference is 0.7 repeating starts repeating from the tenths place. This decimal does not start repeating until we get to the thousandths place. So we'll see some similarities and some differences. All right, these 3 forms are equivalent. I'm going to use this one today. So let's fix that. Actually, I should be using it here. All right, so where's the okay. All right, let's assign z as the variable today. All right, again, the goal is to be able to subtract so that the repeating part becomes 0. So let's multiply z by 10. We get 10z, and that will move the decimal place 1 to the right. So now we'll have 1 in the tenths place, and then it repeats. Notice I wrote it 4 times just to keep things lined up. This bar could go on any of those because the 3 is what's repeating. Oh, I didn't write that very well. Okay, 10z. All right, now we'll try 100z. And so the decimal will go 2 places to the right. And so we'll have this for the decimal, and then 1 in the ones place and 7 in the tens place, and that's 100z. And then 1000z will move the decimal 3 places to the right. And again, we'll have that is our decimal portion, and then 713. That's 1000z. And here I encourage you to pause for a second and think which combinations of the multiples of z will allow us to eliminate the repeating part. Okay, so will these work? Well, here I see the repeating part is the same. So yes, 10z and z will work. How about 100z and z? Yep, repeating parts are the same. In fact, any combination of 2 of these multiples of z will work. Okay, the easiest one's going to be 10z and z, so we'll do that. So we're going to subtract z from 10z, which means we'll subtract 0.71333 repeating from 7.1333 repeating. So 10z is 7.1333. I'm just going to write 3. And z, subtracting z, is equal to 0.71333 repeating. And because the 3 is repeating, we could just put the repeating part here, and we could put the repeating part here, but that would probably be a little confusing. So when we subtract, we do see that the repeating parts subtract to 0. Their difference is 0, so we will be able to show that this is a rational number, a ratio of 2 integers. All right, subtract 1/10 from 3/10. We get 2/10. Subtract 7/10 from 1/10. Well, we don't have enough tenths, so we'll trade a 1, and and we get 10 tenths plus the 1/10 we have. So now we have 11 tenths. 11 tenths take away 7 tenths is 4, I'm sorry, yeah, that's right, is 4 tenths. Okay, and then 6 take away 0 is 6. Okay, and then 10z take away z is 9z. So now we have 9z equals 6 42/100ths, and 9z means 9 times z. To undo the multiplication, we divide, and we have to do the same thing on the other side to keep the balance. So now we have 1z, or just z, is equal to 6 42/100ths divided by 9. Well, we want to have both of these numbers be integers. So if we multiply the numerator and denominator by 100, then that'll move the decimal 2 places to the right, and we'll have both these numbers as integers. So we're going to multiply by 1 disguise as 100 over 100, and that gives us 642 over 900. Okay, so now we've shown that this decimal is a rational number, and it's in fraction form. These two numbers are both integers. Now we want to think, can we simplify this, or is there a common factor in these two? Well, they're both even, so we can divide each number by, well, what we're dividing by is 2 over 2, 1 in disguise in the form of 2 over 2, and then this would be half of 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3. That's getting crowded, so I'm going to write it down here. So 321, and 900 divided by 2 is 450. And are there any common factors? Well, yes, there are. 1 plus 2 plus 3 is 6, which is a multiple of 3, so this is divisible by 3, and 4 plus 5 is 9, which is a multiple of 3, so that's divisible by 3. Sorry for going off on a tangent there. Alright, so we divide by 1 in disguise as 3 over 3, and anything divided by 1 is the same value, so our new fraction will have the same value as this one. And 321, well, 21 divided by 3 is 7, 300 divided by 3 is 100, so 107, and then 450 divided by 3 is 150. So there's our rational number in fraction form in simplest terms. Hope you enjoyed the video and learned something from it. Hope you enjoyed the video and learned from it. If you did, please press like and subscribe. And thank you for watching. Xiansheng.